Okay, let's jump right in. You've handed us an article here with a title that immediately grabs you. The experiments that already proved it. Why vision is sync, not travel.
Yeah.
That's a pretty fundamental challenge to how most of us think about seeing things.
It really is. It goes right after the core idea in what the source calls legacy science, the standard model.
Right, the idea that light travels from something to us.
Exactly. That light is this thing that travels from objects into our eyes or our telescopes. You're basically receiving particles, photons across space and critically over time.
In this article, it's proposing something completely different for vision, for perception itself.
Totally different. It argues vision isn't about receiving anything that actually traveled. It's about sync, not travel. The source says the moment something happens, like a star changing, well, you didn't wait for something to cross the void.
You didn't wait.
No, you resolved a change in a, let's call it a universal state, almost instantly.
Okay, so the mission for this deep dive is to unpack this pretty radical motion theory idea.
Mm-hmm.
And we're doing that by looking specifically at the experiments the source claims already prove it.
Precisely. The article's core argument is, look, we don't need new experiments. Not really. The data's already there.
For things we already know about.
Yeah, from famous astronomical events, even basic physics lab stuff. We've just been kind of looking at it through the wrong lens, the legacy light travels lens.
Instead of the sync lens the source proposes.
Right. That's the idea.
So the tension here, as the source lays it out, it's legacy science, saying light travels, you receive photons, versus motion theory, saying, nope, nothing traveled, you resolve something via sync.
Exactly. And the really provocative claim is that the experiments we trust, the bedrock stuff, actually support motion theory if you just, interpret them this new way.
It's like having the pieces of a clock, maybe, but thinking you're building a B-Nile, as the source puts it.
That's a good analogy from the source, yeah.
Yep.
The pieces are real, the observations are valid, but our understanding of their function and what it all means, completely off according to this viewpoint.
All right, let's dig into how the source applies this. It starts with a really big one. Supernova SN 1987. I think most of us remember hearing about that back in '87.
Oh yeah, a landmark event. Huge news. Astronomers detected this burst of neutrinos.
From a supernova, way out in the Large Magellanic Cloud.
That's the one. And the key thing, the sequence, was that the neutrinos were detected first.
Right, and then the light, the visible light from the supernova, showed up hours later.
Correct. So legacy science explains this time difference pretty straightforwardly, It says the light took about 168,000 years to get here.
Traveling across space.
And maybe the neutrinos, being almost massless and weakly interacting, just zipped through a bit faster or got out slightly ahead.
Okay, standard picture. But the motion theory perspective from the source just throws that whole travel time idea out.
Completely. It argues you resolved the sync collapse of the star the very moment its fundamental rhythm ruptured. Instantly.
So the light didn't travel for 168,000 years.
According to this source, no. What you detected, in real time effectively, was the system stopping its stable sync pattern. Your observing system, here on Earth, picked up that rupture in the, let's say, universal rhythm.
Wow. You didn't wait for photons, you felt the structure break. That line from the source is pretty striking.
It is, isn't it? It suggests the interaction is immediate. It's not delayed by distance in the way we normally think.
So distance isn't a travel barrier for light in this view.
Exactly. It redefines distance. Maybe it's more related to the coherence or the compatibility of these sync rhythms between the source and the observer, not just empty space to cross.
Okay. Let's move to the next example. The source talks about stars that just seem to, vanish without moving or exploding.
Right. We've heard about these puzzling cases, things like VVVWIT-08, or remember the weird dimming of Tabby's star?
Oh yeah, the alien megastructure star, people called it.
That's the one. So these are situations where stars dramatically fade or even seem to disappear for a bit, and standard astronomy kind of struggles to explain it cleanly. Often resorts to invoking, massive dust clouds we can't see or other complex, obscuring things.
And the source argues those explanations are only needed if you assume light has to be physically blocked on a journey to us.
Precisely. If vision is about resolving a rhythm, like tuning into a radio station, then the source's take is different. It's not about something physically blocking light from traveling. It's that the structured motion, the rhythm of the star itself, dropped below the sync threshold.
The sync threshold.
Yeah, the minimum level of coherence needed for your system, your telescope, your eye, whatever, to lock onto it and resolve it. The connection, the loop, as the source calls it, essentially broke.
So the star didn't necessarily go anywhere or get covered up. It's just that we stopped being able to connect with its rhythm. Our receiver couldn't tune it in anymore.
That's the idea presented, yes.
Yeah.
You stopped resolving its rhythm because it fell below that sync threshold, not because something got in the way of photons traveling millions of miles.
This perspective, I can see how it might also apply to those really weird fast radio bursts, FRBs.
Ah, yes. FRB.
These incredibly brief, like millisecond-long, powerful radio pulses from seemingly random spots in the sky.
They're fascinating, aren't they? So sharp, so sudden, and their origins are still, well, largely unexplained by conventional models, as the source is quick to point out.
Legacy science has theories, magnetars maybe, but struggles with the sheer suddenness and how dispersed they seem.
And the source, looking through its motion theory lens, interprets FRBs as real-time sync ruptures.
Real-time ruptures?
Yeah, it suggests that when huge systems out there in the universe collapse or, rapidly realign their structure, it causes instant shifts in the fundamental rhythms they were part of. So your detection system, your radio telescope, doesn't receive a signal that traveled across billions of light years. Instead, it kind of intersects with the pattern of that rhythm collapse as it propagates through the universal structure instantaneously.
So wait, it's not a radio wave traveling like a messenger?
The source is really adamant on this point. It's not signal travel, it's sync resolution. It's about sensing a disruption right now in this sort of ambient rhythmic field that presumably we're also part of.
This idea that perception is instantaneous sync, not light travel delayed by distance, that really changes how we'd interpret images from, say, the James Webb Space Telescope. The source calls it the JWST lookback illusion.
Right. The standard interpretation of those amazing JWST images is, we're looking back in time, billions of years.
Seeing galaxies as they were when the universe was young because the light took all that time to reach us.
Exactly. But then many of those quote-unquote early galaxies in the JWST images look surprisingly mature, structured, which has caused some head-scratching within the standard model.
Yeah, why would the very early universe look so evolved so quickly? It seems paradoxical.
Well, the motion theory view presented in the source is much more direct, almost shockingly so, it says. You are seeing those galaxies in real time.
Wow. Real time.
That's the claim. The source explicitly states there is no past in the sense of receiving old delayed light. You are resolving galaxies whose sync rhythms are still coherent enough, strong enough to interact with your telescope right now.
So the billions of years of light travel, that's just part of the travel story that this theory rejects.
That's it. If vision is based on sync compatibility, not light speed over distance, then, as the source puts it, there's no distance delay. There's only sync compatibility.
So if your system can lock into their rhythm, you see them now, regardless of how far away legacy physics says they are.
That seems to be the core idea. Distance becomes something else. Maybe a measure of rhythmic difference or how hard it is to sync up, not physical spacelight has to traverse over eons.
Okay, let's bring it down to Earth a bit. Telescopes and adaptive optics. The systems that use lasers and deformable mirrors to make stars look sharp instead of like blurry blobs.
Right, adaptive optics. Amazing tech.
The legacy view is pretty clear. The Earth's atmosphere, the turbulence, bends the light photons coming from the star. It distorts the image. Adaptive optics physically corrects for that bending path.
That's the standard explanation, yes. Correcting the wavefront distortions of incoming photons.
How does the source's sync idea explain this? It seems different.
It frames it differently, yeah. It sees it as your telescope system trying to sync to the source, the star. The atmosphere acts as interference, disrupting that synchronization process.
Okay.
So adaptive optics isn't primarily about unbending distorted light rays that traveled. It's about actively adjusting the mirror system to achieve a better alignment, a stronger connection, which allows for clearer resolution, basically a better rhythm lock-in with the distant star.
So improving the sync, despite the atmospheric noise, rather than fixing bent light.
That's the reframing the source proposes. It's about improving the resonant connection, overcoming the interference that messes with the sync process.
The source also uses maybe a more relatable example. Seeing infrared light using special contact lenses. How does that fit this sync picture?
Right. So in the legacy view, you might say those lenses, convert or shift infrared photons into a frequency range your eye can detect, allowing your retina to receive them.
Makes sense of the photon model. But motion theory.
It's fundamentally different. Again, it's not about receiving a different type of particle or shifting particle energy. According to the source, putting on those lenses is about extending the range of rhythms your visual system can detect and resolve.
Extending the range.
Yeah. The lenses effectively tune your eye to new sync bands, different frequencies or rhythms of this universal motion that you couldn't normally pick up.
So you're literally changing your resolution speed or the frequency range you're sensitive to.
That seems to be the implication, yes. You're changing the spectrum of rhythms you are capable of resolving into perception. And the source links this directly, saying, that's vision, that's motion. Vision is framed as this active process of decoding structured motion, or rhythm, not just passively catching photons that flew at you.
Okay, one last big one. The source brings up a real cornerstone of quantum physics, the photoelectric effect.
Ah, yes. Einstein's Nobel Prize work, explaining it.
Right. The phenomenon where shining light on metal can knock electrons out. But critically, it only happens if the light is above a certain frequency threshold. And it happens instantly. No waiting for energy to build up.
Exactly. Legacy science interprets this beautifully with photons. Individual photons hit electrons. Each photon carries energy based on its frequency, EHHF. If that packet of energy is above the metal's work function, boom, it instantly knocks an electron loose.
Below that frequency, even super bright light does nothing, because the individual photons just don't pack enough punch.
Correct. That's the standard, well-established explanation.
But the source looks at this same experiment and calls it a crucial sync test. How?
Well, it focuses on that instant ejection and the absolute necessity of hitting that frequency threshold. Motion theory, as presented here, interprets this not as energy transfer from a photon particle, but as the incoming light rhythm hitting a specific resonance collapse point within the electron's own structure or rhythm.
A resonance collapse, like striking a tuning fork that makes something else vibrate and break.
Sort of, yeah. The source suggests the electron has its own internal loop or rhythm. When the incoming light rhythm matches a particular disruptive frequency for that electron, it destabilizes the electron's pattern and causes it to collapse, outwards eject.
So it's not about adding enough energy, but about hitting just the right frequency to disrupt the electron's inherent sync.
That's the core difference presented. It's about the incoming rhythm disrupting the electron's stability through resonance, causing ejection. The frequency threshold isn't a minimum energy packet needed, but the specific frequency required to trigger this disruptive sync resonance.
Okay, wow. Bringing all these examples together, the supernova, the vanishing stars, FRBs, JWST, adaptive optics, infrared vision, the photoelectric effect, the picture the source paints of this motion theory is pretty mind-bending.
It definitely is.
Vision as rhythm decoding, brightness as, sync coherence, how strongly you're locked in.
That seems to be the idea. How well you're syncing determines the clarity or intensity.
And time. Time isn't depth. Looking back in time isn't about distance light traveled, but maybe about resolution speed or sync compatibility across different rhythmic structures.
That's the synthesis the source offers, pulling from these reinterpretations. It insists, quite forcefully, that the experimental results we already have are all consistent with, and in its view, prove this sync-based model, not the light travel model.
We just read the results wrong all this time because we were stuck in the old paradigm.
That's the argument. We had the data, but the interpretation was filtered through the assumption that light must travel.
So the whole quest in astrophysics and cosmology to find particles arriving from distant sources, hunting photons.
According to the source, yeah, that's legacy physics hunting photons, still looking for the mailman who delivers these packets of light across the cosmos.
While motion theory suggests
you are the rhythm reader. You're not waiting for mail. Your system is actively resolving patterns, decoding rhythms in the universe's fundamental motion or structure right here, right now.
And the source finishes by saying, provocatively, the universe just changed frequency, welcoming us to the sync age.
It's a dramatic conclusion, framing this not just as a new theory, but a fundamental shift in reality itself, or at least our understanding of it.
It's a massive shift in perspective. It suggests that maybe our most basic sense, sight, works in a way we haven't really grasped because we've been so focused on the wrong mechanism travel instead of sync.
It certainly reframes everything we observe, doesn't it? From the grandest cosmic scales down to electrons in a lab, all viewed through this lens of interconnected rhythms rather than particles crossing space.
And that really leaves you thinking, doesn't it? If our perception, especially vision, is fundamentally about decoding and syncing with rhythms, what does that imply about everything else we perceive? What other rhythms might you be sensing? Or maybe more interestingly, what rhythms might you be missing in the world around you just because of how your own system is currently tuned? What the source might call your current resolution speed.
Yeah, something to definitely mull over.